Hey, welcome back to Tripod's Garage. Well, Anet decided to send me their ET5. It's basically a budget big printer. You can find these just north of 300 US dollars. Well, is it worth it? Let's unbox it, set it up, and find out together.
Well, the box wasn't thrown over any fences or anything. It arrived in great shape. So I'm not going to show you that awesomeness of the box sides on this one. But the foam definitely looks nice and sturdy. And look at this. We get a full roll of filament. I think most manufacturers start doing this. You know, it kind of sucks when you get this little sample and you can't print anything with it. So let's remove this first layer and see what we got. We got our little manual here with looks like a parts list on the back. It's a pretty simple, straightforward process to set up this printer. This compartment over here has, what do we have here? We have our power cord. Yes, our power cord's right there. And we have our pair of snips. Seems like some manufacturers are no longer giving snips. I'm glad that Anet still is. And we have our filament spool holder that gets mounted to the top. We got our belt for our hot end. And what else do we have here? Well, it looks like we have our screws with our T-nuts. Not too many. We have our tools, a wrench, some Allen wrenches, and a little screwdriver. What is this thing? Oh wow, now that's a pretty sturdy scraper. Wow, I haven't seen one of those. And we have our USB adapter here with our SD card and already pre-inserted and a spare nozzle. Okay. What? A ruler? Okay, well, that's the first time I've ever gotten a ruler with a printer before. So, alright, let's see if we can get this gantry out of here. It's pretty tightly packed, but yeah, here we go. We got dual stepper motors. It's a very rigid frame. It's all metal, all the bracing and everything. You got your breakout board, a filament runout sensor, and a extruder. You know, all metal extruder. So yeah, yeah, this like build tech type mat with some 3M adhesive on the back, so you can put this on top of your glass plate if you choose not to use the glass plate instead. Here's our hot end assembly, all put together in a nice little baggie. And here's the base. This is very awkward for me to take out, so I'm just going to take it out and put it right on the bench. It's pretty big and massive. So let's go ahead and take this out, put it on the bench, and kick this box to the side here. When you order your Anet, it's going to ask you which region you are, and I chose US, so mine came pre-configured for 110 voltage. However, it doesn't mean that we're not going to take out the back and take a look at this thing. So let's go ahead and rip off the back of this and void the warranty and open it up. Well, by opening the bottom, we are voiding the warranty, and there's over a dozen screws on here, so I'm not going to walk you through all of that. Let's just remove this panel here. Yeah, here we go. It's pretty airy in here, lots of room, everything's organized, and if we look at the power supply, you can actually see the switch right here. So yeah, if you are moving it to another country, you'll need to change the switch. So here's the Chingling power supply, 360 watt, 24 volt. And we see everything's nice and crimped, and everything is routed pretty neatly, I would say. As neatly as you can be, I guess. And let's take a look at this board here. This is a STM32F407 with A4988 motor drivers. So it's going to be kind of loud. Here's your brace bar that goes across. It's a 2040. So yeah, it's got the cover back on, and we will need to put 2 screws in here and then another 2 screws in here for the gantry. So let's go ahead and get this thing ready. First, we're going to take off this little shrink wrap that's holding the glass bed to the build plate. It's an aluminum build plate. Once we get this off, we could go ahead and remove the cardboard that's on the sides. So I have to say, this is packed pretty well for not moving anything. You know, just having these cardboard pieces here, I think is good enough. But they have these little extrusion infills, I would say, that go in the inside the extrusions to prevent this carriage from moving side to side during shipment. Now you can take a small screwdriver and insert it and then pull it. like I am here, or you could actually just take a screwdriver and unscrew the brace that goes across, but that will most likely loosen your belt. And you know what, I'd rather just do it this way. It is kind of a pain, but I think it was more of a pain for them to put it in than to take them out. So it's to help prevent it from shifting during shipment. Now we're going to prepare to install the gantry. This will take 6 bolts altogether for each side. So we're going to first put 2 bolts on with T-nuts, and we're going to make sure they're nice and loose with the T-nuts going up and down, just like this. Then we're going to take our gantry and we're going to place it on there. And then once we do, we want to just make sure that's nice and flush and double check that the T-nuts are in place. Now we're going to fasten it down with 2 bolts on each side. Now, if you've seen a couple of my videos, you know that I'm not a fan of turning these machines on their sides to install the gantry. Now, this is my machine and not yours. You do not have to follow my advice, but I rather overhang the machine and finagle the screws in place to get them in. So that's just me. Now we're going to install 2 pre-threaded screws into the extrusion on its side. Pretty simple and straightforward. And then after we tighten these down, we will now tighten down the ones with the T-nuts. You'll see that they twist in place, and now everything is locked down in place. Total of 6 per side. This thing isn't going anywhere. It looks like Bear is enjoying a nice cool floor to lay on. Now we're going to prepare to install our hot end assembly. First we need to loosen these 4 bolts. This way we can slide the motor back and forth for tension. And here is our belt. Now when we take this belt out, it's all going to be, just all over the place. So don't worry about it. It may not even stay on for this step. So we're going to just prepare to have the motor go over this extrusion. And as you see, there's no belt there. Well, it'll be on the next shot. So let's go ahead and take this out of the bag. You'll see that all the wires are wrapped around it. We're just going to untangle them there. And let's take a look at this. So right here we have our auto leveling right here. And there's a potentiometer on the top so that you could adjust for the height. And everything seems to be labeled pretty well on here. You got your 3B rollers, and then here are your belt mounting points right here. Now we're going to slide the hot end assembly over the extrusion. Now this could be a little bit tricky at first, but don't worry about the other end of the belt or even this end, because it doesn't really matter. We just want to make sure the belt is underneath the top, and if it does, you're going to just pull the sides out anyways. So just make sure it rolls easily. You can turn the machine around. Now we're going to fix the belt to the bottom. You'll see that there's a slot, and make sure that that brass clip is underneath. That'll keep the belt from coming off. Now if you see that it doesn't have enough room, you can just move the motor that we adjusted earlier and give you some extra slack. And this is what it will look like once it's done. Not too difficult. Now we're going to pull the stepper motor nice and taut. You don't want it too tight. And then, move the carriage back and forth. Make sure it rolls with very little resistance, to no resistance actually. Tighten down one of them, and then tighten down the next 3. Now we're going to just double check the hot end assembly, make sure it's moving nice and freely. If you detect any wobble, mine actually is fine. You could adjust the nut on the bottom. It's an eccentric nut. It will basically move the bottom wheel up and down, so that way you can get rid of any wobble. Now we're going to do the wiring. You'll see that there's gaffer's tape holding down the Z stepper motor wires. So we're going to peel that off and then attach the one on the left. Now we're going to go to the one on the right. You'll see there's gaffer's tape holding down this big ribbon cable that will go to our hot end assembly breakout board. And we're going to move that off to the side for now and peel off another piece of tape that's holding down this other stepper motor connector. Plug it in. Now we're going to install the ribbon cable. Now this is a firm fit, so just don't be too afraid. It's going to sometimes take a little bit of force to get this in, but once you do, it'll just snap in and good to go. Now All these breakout board plugs are labeled nice and clearly, and we're going to just match them up to the breakout board itself. Very easy process. Once you're done plugging in all the wires, we're going to now just install 2 zip ties. This is the cable management, and we're going to just loop these around to both sides, make them nice and taut, and snip off the ends. And this will be our basically done with our wire management from here. Now we're going to just attach our Bowden tube. Just push this clip out a little bit, retainer, and push in the Bowden tube all the way. Now we're going to install our filament holder. It just takes 2 screws and then loosely put on our T-nuts, just so that it'll make it easier to install on the extruded aluminum on the top. Now we're going to just assemble our spool holder. It's really nice that Anet gives a full roll of filament. It just makes it more pleasurable that you don't have to go out and buy one. Our belts are nice and tight on the bottom. Don't need to adjust that. This is one massive machine. So we just route the filament through, and you go right through the filament runout sensor, right through this actual metal extruder, and then goes right through the Bowden tube, right to the hot end. Now remember that ruler? Well, this is where it comes into play. Now, this is to align your Z. Now, you can take it on both ends and then mark it, but I prefer using digital calipers. It's just easier for me instead of relying on the ruler, and it's more accurate. So what I'm going to do is I'm going to get the height on this one end on the left, and once I do, I'm going to lock the calipers in place. Then I'm going to bring it on to the other side, and I'm going to twist it down in place to make sure it meets where the other side was in height. And then I'm just going to bring it back to the calipers to the other side to verify that both heights are accurate. Pretty simple. So this will just help with any alignment issues you may have. So I just go back and forth at least once to verify. Yep, everything looked good. So let's go on to the next step. Peely action. Yes, you got to peel. This one wasn't as gratifying as others, but you know what? Still. Now that this is assembled, let's give you a better understanding of how big this printer really is. Since this is a sling bed, you want to make sure that you at least have 29 inches of travel. That way it won't collide with anything. It's over 21 inches deep, just the base, and over 16 inches wide. It's with a full spool, 33 inches tall. The build volume is 300 millimeters by 300 millimeters by 400 millimeters tall. Well, let's go ahead and plug this thing in. Turn on the display, get some leveling done, and some prints. It comes with a touchscreen interface. This touchscreen interface has 3 main buttons. You have your print button, where you can go ahead and select which file you want to print on your SD card. Then we're going to skip to the settings button, because here you can see where you can move the axes, and then if you want upgrade, prepare, and preheat, level, auto level, or manual level, or you can go ahead and change the filament. That is what the menu system consists of. So now we're going to go ahead and do the manual leveling of this printer. To start the leveling process, first we need to drop our hot end and get it level with the bed. To do this, we are going to first hit the home button and let it go ahead and center. But we may need to stop the execution of this if it starts to get too close to the bed. Once we do this, we're going to adjust the height of the Z. And once we do this, we're going to go ahead and insert a piece of paper, make sure it's underneath, and then so it slightly drags, and then once it does, we're going to go to the top of the unit and adjust the potentiometer. So get yourself a real small screwdriver, go to the top, and turn it just a little bit clockwise so it turns red. do the manual leveling of all four corners before we decide to do the auto leveling. And that's standard process, you know, you're grabbing a sheet of paper and just where you can barely, you know, drag the paper across. Now we're going to adjust the Z, basically manually, but we're going to hit the home button again, and as the nozzle drops down, we are going to grab our piece of paper and adjust the height of the Z axis. So as we wait for it to finish, we're going to put the piece of paper underneath, and then we're going to go back to our Z, and we're going to adjust it to where the paper just barely drags. It's going to take some little bit of fine tuning, but once we have it, we'll go ahead and hit OK, and then we'll begin the auto leveling process. There we go, let's go. So now we're going to start the auto leveling. This is sped up by 8 times. It does take a little while for the mesh to be created. As it's going through, you'll notice that the display doesn't show the whole mesh. No worries, it does actually house the whole mesh. So once this is done, we'll hit the home button again and make sure that our Z offset looks fine. Okay, it's time to kick off some test prints.
Well, how's it print? That is the biggest question, right? Well, let's just say I had a few failures, and this is not even half of them. And I just never had such a difficult time. I mean, look at this. Look at this awful benchy here. It was just misery. And, you know, I had a problem with some of the bed adhesion on some of them. It was just absolutely awful. And I just kept on going and, you know, tried different prints. And I'm like, I don't know what's going on here. You know, I even tried, you know, changing it up. And you can see this little curve here. And it just kept on knocking the benchies off. Now, let's just say it wasn't the printer's fault. My wife decided to go shopping, and she saw a sale. And she was at Joann Fabrics and found this filament called Sculptor. It was like $6 for a half a kilo, okay? And so she bought me like 12 rolls of this stuff. And let's just say it is absolute garbage. It did not work on any of my printers. It failed at the same exact spot on all my printers, and adhesion was a definite issue. Do not buy this garbage. It is the worst filament I've ever used. If you have had better luck with it, please comment below, but I'll never go with that brand of filament again. Now, I did manage to get 2 somewhat successful prints of this Sculptor. To get this benchy here, it's not that bad, but it's not to the, you know, to where I think is acceptable. I mean, it does have some very nice lines, but you can see right at the top here, there's some issues going on here. So by some standards, people would say, hey, that's a pretty good benchy, but not what I'm looking for. I'm printing these owls, You know, this is at 0.12. Came out pretty good. I mean, I wasn't expecting to see these type of lines, but it's not bad. You can see that there's definitely some adhesion issue. Towards the end, it was doing a little bit of a wobble. So, yeah, you can see it on the top there. The poor ear was starting to get the brunt of it at the end. So, I decided, let's go with the original roll of filament. And got much better results. With that, though, what I did was I decided, okay, I want to try the filament runout. And this is right where you can see it. The filament ran out. And then you can see it on the, it left a little bit of a blob. So you can see it right here. But because what it does is it just lifts up the nozzle, and then you gotta make sure it doesn't like move it off to the side or anything. And you gotta watch it and make sure you clip off any of the oozing from. You gotta be quick. So I wasn't quick enough. So, but actually, it wasn't that bad. On the other side, it looks pretty seamless, except for right here. And then we can go to a cube here. Looks pretty good. So, not too bad at all. You see some ghosting. I think that's basically from, I don't think it's the machine, I think it's my workbench, because that sling bed, I can feel my workbench right here actually shaking. So, I definitely think you want to have a very solid surface when you're printing with this thing, because it's a lot of kinetic energy with that bed being so big. So I decided, okay, my last print, I'm going to do a base mode. I have to say, pretty darn impressed with how this came out. Very big print, and you can see the ghosting more on this. So again, I never had a problem with the ET4 Pro and with ghosting, and I could feel my workbench kind of shaking. So you definitely want to make sure you have it on a stable platform. But I think that actually looks pretty cool, to be honest with you. You know, it gives it even more of a 3D effect. So this is only a single layer, but yeah, I think it did a pretty darn good job. This was a 12-hour print. It's actually one of the taller models I've done. So, but let's go ahead and see what my final thoughts are. So what are my thoughts about the Anet ET5? Well, I think you get a lot of printer for just north of $300, US dollars that is. I mean, look at the size of it compared to the, you know, the Anet ET4 Pro. I mean, it's massive. And you get this 300 by 300 by 400 millimeter build volume. I mean, it's good enough to build a lot of things. So, I mean, you get the touch screen, you get auto bed leveling, you get the dual Z rods, a glass bed, and you get this, you know, a sheet of, you know, it's like a Build-Tech surface if you want to put it on there. And it actually heats up pretty quickly. So, yeah, it's not that bad of a machine. But of course, there's always some, you know, needs for improvement, right? Let's talk about assembly. Assembly was very straightforward, easy to do. Took me about 25 minutes to get everything up and running. However, when I was moving the Z up and down, I noticed that there was a little bit of a squeak. And the squeak is typically the rods in the back need to be lubricated. And they were actually kind of dry. So what I did was I wiped them down with a lint-free paper towel, and luckily I had some 301 PTFE lubricant. All it takes is a couple drops of this on each of the rods in the back, and you're done. I mean, this bottle of pipe most likely will last you for years, and it's always worth to have around, okay? So, definitely. As I mentioned on the ET4 Pro that I reviewed, I would like to see some end caps for the belt, you know, just for safety reasons. And underneath I would like to see, for the heated bed, a better strain relief. and you know, just would be nice. For the hot end, I would like to see a silicone sock, you know, that just because it should have one. It helps for cleanup. And you know, I think the touchscreen by now needs a new update, but honestly, it's still not that bad. The machine isn't that loud. I was in the next room, I could barely hear it. But if you want, you know, Anet does really have a silent board available. I may do an upgrade on this later on and do a quick video on it. But honestly, it's not that loud compared to my Anet ET5 Plus. When I first got that, before I put a silent board in there, you could hear it 2 rooms down. So yeah, I would definitely recommend this. You know, I think it's worthwhile. So I really appreciate you tuning into Tripod's Garage. If you could please like and subscribe, that would be great. If not, I understand. So I wish you a pleasant day, evening, or weekend, or whenever you decide to watch this video, and thanks for tuning in. Catch you next time.